Okay, so for our first lab, we're going to need to use an electroscope. So I have a very quick video here just to kind of show you what an electroscope looks like, all of its parts, and kind of how it works. And so that when you come into the lab, you can get started on picking your substances rather than trying to figure out how the electroscope works. All right, this is what your electroscope looks like. Okay, it's basically a steel box with open sides that are covered by thick pieces of glass. All right, so here it has a metal ball sticking out that's called the conductor. All right, and then that metal ball is connected to a metal pin that comes into, it looks like, I hope you can see it, like a little rubber stopper. That's called an insulator, right? So that the electricity that's here is going to actually come all the way through. And then that metal pin comes all the way through the box into the inside of the box called the lead-in. And the lead-in has little hooks, and attached to the hooks are two pieces, they're side by side right now, of gold leaf. Gold leaf is a flat piece of gold. Gold is actually a relatively soft metal. It is what we call malleable. So you can take a piece of gold and you can put it into a huge press and flatten it into an incredibly thin sheet, kind of like tin foil or aluminum foil. It's the same thing. You take a piece of metal and you just flatten it really flat. You can do the same thing with gold. Okay, so this is an electroscope at rest. Here's the conductor, insulator, lead-in, gold leaf. If you take something that has excess amount of electrons, that is charged, those electrons will jump to the metal ball, the conductor, because it accepts the electrons. So this would become the electron donor, this would become the electron acceptor, and those electrons would then go through here. They'd stay on here. They wouldn't go onto the metal box because the insulator keeps them there. And then they would file onto the very thin pieces of metal at the bottom. Because just like for the Van de Graaff generator, if those two pieces of metal become similarly charged, they will repel each other. And they're floating here in this big box of air, again, because air is a great insulator. So now I'm going to actually show you the electroscope at work. Okay, so this is the electroscope you're going to have on your table. And you'll have just a simple latex balloon. And I'm just going to show you guys what a positive reaction looks like here. So you know what to be looking for. All right, so we're going to charge up the balloon. Latex is a great electron acceptor, so we're going to give it more electrons, but just by rubbing it on my head for a little while there. All right, so the electrons from my hair have now gone onto the balloon, and you don't need to touch it, as you can see. You just need to bring it close enough. All right, so those electrons are going to jump through the air and onto the metal plate on the top there, and you can see that those electrons are then going to go down the lead-in. They're not going to disperse here because of this insulator, but they're going to go down the lead-in and into the gold leaf, which then becomes negatively charged, and the two repel. And you can see that that is a very positive charge. You will probably not see a positive charge this big, and that is maxed out. Now remember, in the pre-lab, you can't use a maxed out signal. We're trying to figure out which one of these, which electron donator is the best. Now, this is still charged up, and that's because the glass, again, is keeping this air in there. It's an insulator, so the electrons can't get away, and they're not touching the metal at the bottom. So to discharge it, all you need to do is take your finger and touch the top. And you can see that the leaves pretty much go back to normal. Right? At no time are you going to open up this box or touch that gold leaf, because it is actually pretty hard to come by, and we don't want to rip it. That would be bad. All right, so that's how the electroscope works. So now you know what you need to build the rest of your pre-lab.